have that, right?
Yeah.
Or you have that, what does the 4 do? When you say, okay, yeah, it times this by 4, what does it do to the graph?
Oh, makes it positive, makes it more steeper.
Makes it steeper, right? It stretches it that way.
Yeah.
Same thing. If you put something there, it's going to stretch it. Okay. It just makes it grow faster. But H and K don't move. Okay, I'll put it in A here as well. There you go. So you can have anything out there and it'll stretch up. Yeah, that'll take care of that for now. Cool. Cool. So we've made one generalization. Fantastic. Hopefully we'll actually get through this today. Okay. Cool. All right. Next thing. Well, now we've got all this. Well, let's draw an axis. This thing's already factorized for us, which is nice. What does that allow us to do straight away? Right, x-intercepts, yeah? 1, 2, 3. 1. Oh, that's terrible for symmetry. Alright, 1, 2, 3. Cool, alright. So, what are my x-intercepts? Positive 1, negative 2,
And
positive 3.
4.
Those guys, yeah?
Fine.
Cool. Now, I've got all of these in a straight line. Is there any way I can draw this shape to satisfy those 3 points?
Yes.
Okay, so it looks like we're going to need some sort of thing that actually goes up and down, some sort of wave. Right? Okay. And you're good on that, by the way. Well, what might be an easy number to calculate with?
0.
0, right? Let's figure out what happens when it goes to 0. Okay, well, these just become the numbers in there. Negative 1 times 2 times negative 3. 6. So I'm just going to say 6 is there for now. That's now 6. Cool, so it has to go through there. Alright, well, if I just connect the dots at this point, we're going to get this has to go up and then come down. Well, this thing, presumably, it could bounce, that's possible, but we can test it by chucking in the point 2. Okay, 2 minus 1, 1. 2 plus 2, 4, so this is now multiplying 4. 2 minus 3, negative 1. Negative 1 times 4, negative 4. So this thing ends up negative something. Cool. Cool. So we get that. Cool. So they've all got 3 separate linear factors. Ooh. Ooh. You just get a nice quick through them all. X minus plus B. Minus D plus B plus C. Oh gosh. There we go. Cool. So that's our general form for that. Right, again, that A, all it does is it stretches it, but it doesn't change where the intercepts for this one are. Cool, cool. Alright. Okay, are we okay with that guy? Yeah. Alright, well, taking a look at this, what do you think it's going to do? Same sort of thing makes a bit of sense, yeah? Because we've got all that. What's the only difference? Cool. So it's negative, so it's going to right, flip over, right? Upside down, flip over. Cool. So I'm going to massively shortcut this and just write that's now negative 8. This is now negative 2. This is now positive 4. Now, is my thing to scale?
No.
No, right, I didn't measure anything, right? Is it in order?
Yes.
Close enough, right? So this is where we start to deliberately get a bit lazy with our graphs because we don't care about minute detail at this point, we care about the general shape of things. Cool. Okay, so I've got to connect those 3 dots. Alright, and we think that because of this negative, the whole thing should go upside down. So instead of starting in the bottom left, I'm going to start in the top right. Sorry, top left rather.
So 2 times 4 is negative 8, negative 8 times
Something like that.
is It's 8 times 8.
Cool, cool. So it's the same thing, just flipped over.
Negative 60.
Cool, alright.
Thing is negative 60.
You should always double check your thinking by figuring out what your y-intercept is.
Negative 64.
Negative 64, okay, so 2 times negative 4, negative 8, times 8,
Negative 64.
negative 64, times negative 1, positive 64, this must be up at 64.
Alright. Pretty right.
Cool, cool. Right. And that makes sense, it's on the positive side, so great, we've confirmed our own thinking. Fantastic. Alright, next guy. This thing. A little bit weird. Oh, we'll try it anyway.
X plus 2 and x minus 4.
I'll actually do this one slightly to scale. Yep, okay. Cool, alright. So x plus 2 and x minus 4. Okay, what's weird about this?
32 points.
There's only 2 exit steps. We had 3 before, or 1, but never 2 before. Yep.
Oh, just a quick question. In
Yep.
tests, will we need to find turning points as well?
Eventually, when we do calculus, yes. Right now, no. Good question, mate. What's it on? Right, so we've only got 2 this time. Oh, that's a bit weird. So we'll think about it and go, okay, well, if I had a y-intercept, that would be handy. Okay, y-intercept, put in 0, negative 2 squared.
16.
Right, it's become positive 4 times 4, 16. So I must be up at 16 somewhere. Okay. I've got these dots. So either, I could go like that, but that's just a quadratic. So that doesn't seem like that's how this should play out with
So you
cubic.
like that?
Okay, so there's a couple of ways that you could connect the dots, right, at this stage. Here's what we're going to do. We're going to create some more dots. If I was to take a really, really big number, right, so I'm thinking way off this side. Okay, big number minus 2, still a big number. Squared, even bigger number. Big number plus 4 is another big number. Big number times big number,
Huge number.
big number, right? But they're all positive is the important bit. So I'm going to race off this way. Cool, cool? Okay. Same thing, a very negative number. A very negative number minus 2, still a very negative number. Squared,
Another big number.
a big positive number. A very negative number plus 4, still very negative. Very negative big number times a very big positive number.
Big, very, very negative number.
Very, very negative, right? So we're way down there somewhere. Cool, now we've got more dots, right? The last little trick is where this thing goes. So, actually does that. The reason it does this bounce is because of that square.
Makes sense. Because now
This is 2, this is cool. So I've done the general thing. X, A lots of x minus b squared, x minus c. B, cool. So if you've got a squared factor, you're going to bounce off the axis. Cool. Yep, okay. Last one. Okay, I've got this. Does that match the form of any of our predecessors?
Yes.
no. They're all
Well, not the current way it's written.
Oh, wait, which one are we doing?
This guy.
Oh, yeah.
Alright, it's all expanded out. Okay, what's the first thing you're going to do?
Figure out what the factor
Find a factor and do that, right? Conveniently,
We already did.
we already did that.
Yeah.
So, first thing you always do is switch it out. Okay, if you can. What did we end up with? X plus 2
+5.
plus 5 minus 4. Thank you.
plus 5 minus 4.
Good work, teacher.
Cool, so we end up with that. Great. Is this of the form that we've seen before?
Yes.
Yes.
Yeah, right, so now we know what to do with it, yeah? Bang, bang. Can't be bothered with accuracy. 4, -2, -5. Cool. Connect the dots, it's a positive one, so it will end going positive. Something like that.
-40.
Cool. -40, how do you know it's -40, TJ?
Times 2 by 5 by 4.
Okay, even slightly faster way,
Because D.
because it's up there already. It's already expanded for you, right? So you can do it that way, there's nothing wrong with that. Right? But this is the thing, there's always a heap of little shortcuts just to save you a second or two, or at least to clarify your thinking as
Will that
well.
always be the answer?
Will that always be the answer?
Like that -40, like that D.
Oh, will this always be there?
Yeah.
So long as it's of that form, yes. If it's fully expanded, yes.
Oh yeah.
Right? But there's going to be later things where it'll have something, 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 and then -40, but the y-intercept won't be -40 because of what the something, something is.
Yeah. Okay.
Cool. That's that. That's not a new form, that's back to this, so I don't have to draw any new thing.
Oh, so
Yep.
when we do you know those points on the right and the left side, on the top
As
right.
in this and this?
Yeah.
Yep.
Do we have to point those points?
To point the points. You don't have to, no.
So do we do, or can we just draw it in that direction?
You can just draw it in that direction, it's totally fine.
Okay, cool.
Right? The only reason I put that is just to illustrate what our thinking was. That's it.
Okay.
Cool, cool.
Man, I need to write that.
Last little thing is if A is less than 0, it's negative, so the whole thing will flip upside down. And we'll go that way around. A is less than 0, whole thing's upside down.
Should have done it.
0. Happy days? That's it. So we've still got 20 minutes to go. Cool. Any questions about anything? No, we're okay? Cool. So yeah, that's 6. 6D is just solving. For the most part, it's already factorized for you as well, so it's super quick. And then they'll give you unfactorized ones, which just means factorize it one way or another. You can pretty much always use polynomial long division, but obviously it takes time. So if you can find a cheaper, easier way, great. But sometimes you resort to it. That's all 6D, and then 6E and F is graphing the different types of these. Cool, cool. Have fun.
Thank you. Thank you.
Sure.
Yep.
It means solve the following. You just do x + 1.
Yep, that's it. That easy.